I had a question. It's a neutral one, I think, because it's not trying to really disprove one or the other. Some it relates to like based on what we see. Should we believe it? And like, should we just believe what other people tell us? Because I'm a skeptic in terms of that stuff. Like, we should definitely verify anything, right? Before we think it's true. But the question, so because I'll think like, yeah, I've never been up high enough to see if the Earth is a globe or anything about what it is. But if I walk outside and I think about what we talk about when we're in here, because I've been in here for a few days, a couple times now, that, and I don't mean this in a dismissive way at all, but
Is this a
like,
recording?
if the surface I'm on is,
Is this a recording?
sorry,
You,
what
you
I'm
sound
saying
like you're
right
reading
now?
from a script. Yeah, it just sounded like you're reading from a
No, but
script.
I've thought about it. No, sorry,
Okay,
I've
go
thought about
ahead.
it. You know, I
I
thought about
just
it
had to
before
interrupt to
coming
make
on,
sure, man,
but
because people
I
come
have
in here
like,
with bots and shit. I had to make sure.
oh yeah, no,
People come in here with
no,
AI and
I
bots
did.
and talking shit. So
Oh, it's probably annoying as heck. Yeah. But it's a really simple question. I guess I'm trying to build it up by all this boilerplate. Sorry about that. Is like, if I believe the surface is flat or if it's curved, does it make a difference to my life? That's what I'm asking myself. You know what I mean? Like, well, what if it is curved? What if it is
yeah, it
flat?
does.
Like,
I mean,
if I'm a glober, right? You know what I mean? Like,
the
uh,
physicality of it doesn't make a difference. The existential
yeah,
consequences are what makes a difference.
right, yeah. So I feel like I feel like I can see it both
Because
ways,
there's
and that's
actual
why I come back to
existential
like,
consequences to one versus the other, right? So you can't support. You can have an atheist materialist worldview with a globe. You can't have it with a flat Earth. There is no materialist atheists worldview. Can't support it. That's the major thing. That's what I mean by
I don't have all
existential consequences. Why you
I don't
exist,
have all
where
the
you are,
answers.
what all that stuff, all the existential questions.
It makes it harder to, if there is no curve to the Earth, it makes it harder to believe that it couldn't have been
No,
designed.
there can't be
Am I
a
saying that right?
big bang materialist universe.
Okay. I'm
What,
not
so,
thinking about arguments, I'm, like, trying to process it. I'm new.
yeah, I
So,
know. So like just existential questions, right? Like
yeah.
where am I? And now talk about in the grand sense. Where am I? Who am I? Why am I? You know, existential questions of, you know, existence. Say all the other human beings just vanished and you were born yesterday. You'd have all these questions. Why am I here? What's my purpose? Where am I? All these questions. Now, the globe is one answer. Flat Earth is another answer. The globe has certain consequences. Flat Earth has certain consequences of the where am I question. And from the where am I question, you can ask the other questions. Why am I here? Right? So the globe is the foundation for a um, materialist atheist worldview, where the universe is a purely mechanistic device, basically. And there's a big bang, and then random shit happens, and then there's evolution, and then there's people. So you hear all that? That's a creation story. Science, so-called science, has a creation story, even though it's an atheist creation story. So there's no deity driving this. There's just mechanistic nature driving all this. Now, flat Earth, there is no mechanistic atheist mechanism to make a flat Earth. So it must be created by default. It's the only way. It's created or uncreated, what's called the ontological primitive. It has to be created. And then if it's created, then there's all the consequences that follow from living in a created realm. Who created it? Is he a god? Is he not a god? Is he a fucking alien? Is he a freaking demon from another dimension? You know what I mean? So there's all those questions that come after, but there can't be the mechanistic worldview where there is no purpose, right? There's no sentient thing driving it or ever drove it.
So, like, If does it also mean that we're probably the only place that has life? Is it kind of implied in that too?
And well, I mean, so far,
Um,
all indications are that we are the only place that has life.
yeah.
I mean, people
Okay.
speculate that there's life other places, but that's just speculation. And 50 years ago, when I was a kid, if you believed in aliens, you were a crackpot.
Right.
Now it's just mainstream from repetition of the media and all those things. Now people think it's possible, even though if you take all the physics that we know, there's no way, there's no mechanism from which we could ever get to like another like if you this is an internal critique of the globe idea, okay?
Mhm.
So
Yeah.
even if all their physics and they had infinite amount of money and any freaking infinite amount of intellect and whatever, even within the paradigm, according to the physics they know, it's pretty much impossible to get to another star in any human scale time frame. So, for instance, they say they launched Voyager. It won't be the closest star is 4 light years away, according to them, right? It won't get there
Yeah.
for 150,000 years. Okay, that's the
Mhm.
closest, and you have to assume does the closest star have life, right? Maybe the closest star that has life is 20 billion light years away. You know what I mean?
Right.
I mean, could there be? I mean, in the current paradigm, there is like they talk about all the stuff being out there, but it is pure fantasy because they can't verify it. They can't even within their paradigm. None of it can be verified because they say we can't get there. It's too far away.
Even if they got there, it would take forever to get that data back, if it, in some way, or who knows what would
Yeah, and
happen
that's
to
the
it.
other problem. Even when you get there, how are you going to tell anybody?
Yep. Hmm. Yeah, it's a mind fuck.
All that stuff like the space travel. I mean, we've been lost in fantasy, like the Western civilization. We've just been lost in the fantasy that, and Elon Musk is no help telling people we're going to Mars in fucking 5 years and going to the moon in 2 years and we're going to have a base up there and shit. They've been saying that shit since 1970s.
True. Yeah.
I mean, you could buy tickets to the moon from Pan American Airlines. They were selling tickets.
Oh, that's right. I forgot about that, right? The Katy Perry went up into space or whatever. I completely forgot
Well,
about
yeah,
that.
there's that. I'm talking about in the 70s, Pan American Airlines was
Oh,
selling
really?
tickets to the moon.
Huh.
Yeah, they thought during the Apollo program, they thought freaking like space tourism was just like right around the corner. That's what they're telling everybody. It's right around the corner, a couple years. They're still saying a couple years. I've been hearing a couple years for 50 years.
Right. Yeah. Yeah.
So, and I mean,
Yeah.
that's the only like there's no practical consequences. The consequences are more metaphysical.
I gotcha. Yeah. That's why I like can't I wouldn't be able to deny flat Earth either. You know what I
I
mean?
mean, I guess the practical consequences could be like military and communication. I mean, those are practical. If there isn't a big ball in the way, then well, I'll give you for instance, in a very particular example. During World War II, the Germans had invented a radar system called the Knickerbein, which in German means crooked leg. So, from two locations in Germany, they sent radar beams that crossed each other over England, and their planes would fly within the beam, right? One beam emitted dashes, dash, 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 and the other beam emitted dots, dot, dot, dot. And we were at they were intersecting the beam over the target that they wanted bombed. So when you got dashes and dots, you knew to drop your bombs because you were over the target. Well, here's the problem. Fucking from the line of sight from Germany to UK is 11 miles under the horizon. Okay. So you got a fucking problem, right? And
Yeah.
so when they did shoot down some planes. This is how they found the English found out about it. There's a video about it. It's called The Secret Wars. In the first segment, the scientists that actually did this talk about it, and uh, they got a couple pilots and they're recording their cells, and they heard them talking about it, and they noticed that some of the planes that were downed, they had radio equipment that they couldn't figure out what it was, and they said something. So one of the scientists figured out they're using it as some fucking bombing system and that they're beaming it from fucking England. And all the other scientists in the War Department said, "You're crazy. Earth's a globe. That's impossible." And the guy had to go to Winston Churchill himself just to get a plane to go up and see if they could detect the beam, to detect a radio signal. Then they did. They went up. They detected the radio signal, and and then they jammed it and did all sorts of stuff to it, right? But that is a practical thing where the globe mattered, right? People probably died because a bunch of scientists thought the Earth was a globe and thought they couldn't shoot radar that far, and they could.
What was it called again? The Secret Wars for Germany and UK, if I look
Yeah,
that
the
up? Or,
Secret Wars.
Knickerbein. If I look up Knickerbein.
The Knickelbein is Knickelbein. But I can post the Secret Wars it's on YouTube, so I'll just find it and post it.
Okay. I'm curious about that, yeah. Yeah, because it's pretty fascinating when it comes to the larger scale engineering problems that would cause this to emerge, you know? That's interesting. I think that's really fascinating. Because I can't do anything with my eyes, you know what I mean? There's, like, nothing I can really do.
Yeah.
But,
So right there in the chat.
this kind of stuff.
So I put in the chat. So there's another one too. So in World War One, it's always funny because this is where the practical application really matters. If people don't like dying, you're allergic to it. So in World War One, a guy in Australia noticed that he was picking up radio signals from Berlin, Germany. Now this is in Sydney, Australia. This would be antipode, nearly 10,000 miles away under the globe from Germany. And he noticed this, so they decided that they're going to try to. And this is the funny thing, is that in World War One, they didn't say this can't happen because it's a globe, but for some reason in World War II, all of a sudden it's a globe, and now they can't do these long-range radio transmissions. They were already doing it during World War One because they set up a system. It was at Cornwall, England, UK, and they set up a teletype machine that would send messages to Australia. It's 10,000 miles. Now, how do you do that if Earth's the globe, right? It's on the other side of the globe.
Yeah.
Right, so there are practical applications. I mean, there's LoRa chirped radio, which goes like 800 miles. NATO's their microwave system was 820 miles. They had an old Cold War era microwave system. There's also what is it? They call OTHB radar, which goes to like 4,000 miles.
Oh, yeah.
They claim that
I
they
was
can
just
pick up
looking that up right
aircraft
now.
in North Korea from Australia.
Over the horizon radar, is that what that is?
Yeah, OTHB.
OTHR,
Yeah,
or is it
they
something
call it
else?
over the horizon.
I was literally just Googling that,
OTHB,
like,
and
I was
there's
looking at this
OTHB and OTHA, and it depends on the frequency or the wavelength, what they call it, one or the other.
Is it alpha or beta or something like that, or the I'll look it up,
Yeah,
sorry,
like
I can do
they
it.
just named it AB for whatever reason. They didn't consult me on their naming convention.
Yeah, right, okay.
And then there's
I
more,
got
right? So Admiral Byrd was in Antarctica, supposedly, Little America, and he did a weekly broadcast on CBS radio in the tower that picked up his transmission. This is 1936 now. Was in Riverside, New York, which is on Long Island. He was in Antarctica. And there's another instance where JFK, when JFK was assassinated, the Secretary of State was somewhere between Hawaii and Japan because he was doing Secretary of State. He was doing like some foreign visit to Japan, and he was in between Hawaii and Japan. They radioed him, and there's the transcript of the White House talking to him and telling him the president's been shot, turn around. Now he's 6,900 miles away.
Hmm. Fascinating.
Yeah, so like you have certain practical examples. Those are practical, technical, exampple.
It
I
was.
mean, for just a
I'm
normal
really
person, it
I'm
wouldn't
really
matter.
sleepy. I wanna note that down. I'm really sleepy, so I have to actually type it out. I won't be able to just remember the over the horizon stuff, I'll be able to remember that, but A and B, for example, but you were saying,
Yeah, there's
it
there's
was
all
Jefferson?
there's all sorts.
1936?
So
I'm
they
all
came up with a reason. They came up with a reason after they were already doing it on how they could do it. They said, "Oh, there's an ionosphere, and the radio waves must be bouncing off of it." Well, that's all fine and dandy, but it's called tropospheric scattering or skywave propagation. It's one of these two names that they use. Now, the thing they forget to mention is that only work that the long distance communication at the frequencies they say, if it's during the day, should only go 500 miles, right? But the Marconi system from the 1918, he discovered it during the day, the 10,000-mile radio propagation. Because the ionosphere is supposed to there's supposed to be multiple layers. And this doesn't make sense to me, and it never has. The night side, for some reason, you have further propagation on the night side in the globe model than on the day side. And no one's ever explained why, or even come up with any reason that I've ever heard on why you can send radio waves further at night than during the day. I have my hypothesis. I think it's called radiation resistance.
Yeah.
Yeah, so if
I've
you have
heard
an
that
antenna,
vaguely. I've heard vaguely that during the day, the waves can be weaker, but that's my recollection of that pretty
yeah,
weak.
I
It was in
wouldn't
some
doubt it.
class in community college. Yeah.
Yeah, there's something called
Oh, go
radiation
ahead.
resistance. So if I have like an antenna, right, and if I take another antenna that's an emitter and like beam it right at that antenna, you can basically trap the radiation from that antenna. It can't escape it, right? Because it's like, think about it like this: you have a wave coming from like a small lake, and then the wave coming in from the ocean. It'll just overwhelm it because the volume of water is so much more, right? Or it's coming in faster or whatever. So that's basically what it does. There's more it has a higher amplitude radiation, so it can just push it. It stops it, not completely, but it stops the antenna from radiating. It's called radiation resistance.
Okay.
Okay, so it has to do with impedance mismatch and shit like that. But I don't want to get into all that. Um,
So
Now, when the
long,
sun's out, the sun is an emitter of every wavelength. The sun, the sun is as far as like a radiation emitter, like electromagnetic radiation, it emits in every frequent wavelength frequency. Like if you had a measuring device, you could measure individual wavelengths down to like the 20th decimal point. It's pure noise as far as electromagnetic radiation goes. Now, some are
okay.
more intense. It's brighter in some wavelengths than others. The point is that it doesn't matter what type of antenna you emit. If the sun's out, you're going to be getting some radiation resistance from the sun, no matter what frequency you're emitting at. And I think it has something to do with that, but that's just like a hypothesis. That when the sun's out, the sun impedes the frickin' radiation being emitted from antennas, but when it's nighttime, it doesn't, and the radio waves go farther.
A friend of mine I think she's in Iran. She was saying that she likes to use
Yikes.
the internet at nighttime because it's better. Yeah, I mean, she's got all that stuff going on. She's a graphic designer, and she says that she'll wait and work in the middle of the night because the internet speeds are faster because the sunlight isn't out. Well, there's less people. No. There's
Yeah,
less
it could be
people using the
sleeping
internet.
too.
That's why I'm wrong. I think I'm fucking mixing this up. And there's just less people online. I think I'm wrong there. Never mind.
Yeah, but
I'm
they
so
probably connect through wireless internet, like cell towers or microwave links or something like that. I don't think they're running cable in Iran.
so I might have spoke too soon there. I realize there's also less people online. Oh. Well, I'm in Germany, so it's getting close to like 4, actually close to 4:20 AM. I gotta fall asleep soon. It was nice talking to you though. I took some notes
Yeah,
on
man.
some uh
Yeah, we're here all the
um,
time, man. Come back. You might not talk to me, you talk to somebody else. Everybody here is pretty knowledgeable about, this topic and, all that, because this topic covers a lot of other subtopics, like what we were just talking about, freaking radio waves, right? So, like flat Earth versus globe Earth, it covers history, science, physics, sociology, psychology. There's just so many. It touches everything because like a base idea that people have. I mean, it's people all around the globe. I mean, put it this way: I was watching a western, and those motherfuckers said a planet in the western. Now, people didn't talk like that in the 1800s. They weren't talking about the Earth
right,
being a planet. Okay, they just didn't
yeah.
talk like that. So it's just like, but they don't even. It's so in the modern vernacular that, like, when they wrote the script, they didn't even think twice about writing down planet in as his dialogue.
Yep. I know what you mean. There was a computer show called *Halt and Catch Fire* about the computer revolution in, like, the early '80s, and a guy was calling something a killer app, and people didn't use that phrase. This is my
Oh my
I don't know,
lord!
they wouldn't have called it an app like it's a cell phone, fucking like it's a smartphone or something. Anyways, that's something I noticed, but I and then in your side of things, you probably would have picked up on, that term being used in the calling something a
If they
planet.
said killer app in a freaking '80s movie
Yeah.
about computers, I don't even. I'd probably blow a gasket.
Yeah, *Halt and
I
Catch
hate
Fire*
shit
is a
like
cool
that.
series, but it was a cool series, but there was that little blip and throughout the dialogue or whatever, throughout the script, so,
Fire that script
um
writer immediately.
the other stuff was alright. I was like, I'll have to overlook that part, but whatever. So, yeah, if I was into this kinda stuff you're talking about and also watching Western, maybe it would stand out. Maybe I would have noticed it like, "Huh, seems oddly educated," like, or this is literate even, like, for what, the 1800s, so,
Yeah, but he was like, it was that freaking what is it? 1873. The Yellowstone series, the one that happened before that. It was the freaking old guy. So he's like 70 years old and 18 something. So like he ain't calling Earth a planet. I'm sorry.
yeah.
Dude grew up, it was freaking 17 something. You know what I'm
Was it
saying?
Yellowstone? Was that the name of the
It,
series? It
wa-
was Yellowstone?
yeah, it's the Yellowstone, but it's the
Okay.
one with think Bill Elliott is it Bill Elliott? Yeah, Bill Elliott is in it. They're like going across. It's like the first they made, like, there was Yellowstone, that TV series. Then they made a series of um when the Dutton family first went out to Montana, right? So that series where they start off like in Texas and go, this whole drama of them, and his daughter gets killed in the end, yada yada yada. I don't know if you know what I'm talking. It's called like 18 something.
I haven't watched any Western series, so I'm not gonna be of any help, trying to remember the names, but it's starting to sound interesting. I bet I can find it. Might fall asleep to it tonight.
Yeah, it's pretty good. I wouldn't say I watched the whole thing, but watched most of it. But it's good. It's good for a Western, though. That Yellowstone series annoys me because that little Dutton family is a bunch of fucking sociopaths, and they kind of like glorify it. It's kind of aggravating when you think about some of the shit they do, branding people. Well,
Yeah.
they volunteered. Oh, they didn't have much of a choice. The choice was, oh, hit the road and be homeless in freaking Yellowstone, or take a fucking brand.
Right.
Dude, anyone even propose to brand me? I'm like, oh yeah, I'll do it. Dude, they're the ones getting fucking branded. Just wait. I'll go along with it right until they're close to me with that fucking iron, dude, and then they're getting it right in their face. Sick, dude. I mean,
But
I know it's a TV show, man, but like I think that, it's like boiling frogs, dude. We take these degenerate ideas, man, and we just we get desensitized to them.
right. Yeah,
I don't like it.
just accept it as what it is, and then later on, oh, by the way, we were wrong the entire time.
Yeah, dude. Like
It's
even
not
the
considered like that.
Epstein thing. Not to bring him up, but it seems like the reaction to that is tame, dude. Dude, everything should be on fucking fire. Like, I'm serious, dude.
Yeah, yeah.
200, a
I know
100
what you mean.
years ago, everything would be on fucking fire if that shit came out.
I agree completely. There are not enough wood chipper sales going on right now.
Bring back freaking. I mean, think of they had riots over this 40-day work week. You know what I mean? Like, fucking pedophilia, dude. Man, there'd be 20 million people in frickin' Washington with guns, dude. Like, I'm not saying anybody should do that. That's not what I'm saying. I'm just saying, like, I'm very underwhelmed by the response.
Yeah.
But whatever. You don't have to worry about that in Germany. There's only not good people in Germany, right?
Well, right. Yeah, sure. I can't pretty much keep myself. I'm only good.
Safer that way.
All right. I gotta go to sleep and try to get up and be helpful at work tomorrow. But it was really nice talking to you. I took some notes on some of
All
the
right.
stuff we talked about. Really appreciate it.
All right.
So
All right. Cool, man.
yeah, have a good rest of your
Thanks for
night.
stopping by. Good talk.
Yeah, glad I did. All right, have a good one.
Bye. Oh my God, a normal person. I'm confused.
Shit, you got me, man. I think the Earth is like a fucking turtle.
Nobody said
Yeah,
anything
well,
like that.
that's ridiculous. Yeah, that's ridiculous. But in reality, we are measuring the Earth flat. We're not able to measure any rotation of the Earth.
No,
So in
we
order
can't
to
Yeah,
measure
believe,
rotation. Like, if you're on a
I just
ship
posted a
and
link for you.
the ship goes behind the horizon and just falls off, like, you can't measure that.
no, but we have modern technology now. So
Yeah,
we
do
know,
you have eyes?
we know with
Have you ever
modern
looked at a
technology,
ship
Bitgood,
leaving?
let me respond to you before you try and respond to the response I haven't even made yet. We know that when a ship goes beyond the horizon, that it's not physically obstructed by the curve of the Earth. How do we know this? Because now we
How?
have modern cameras and high-powered zoom lenses. We can bring
Mm,
that ship back into view.
can you? I mean,
Yes.
what do you do for a living?
Well, that's got nothing
You
to
don't
do
need
with
to. You
bringing a
don't need
ship
to
back
know what
into
I do.
view.
No, it's because I am
Hey,
a sailor
get good.
and I
Get good.
like
Get
do
good.
this all the
I'm gonna
time. I just
get
look
good.
at ships.
Get good.
Good.
Check
Stop
it out.
talking through people.
I'm going to post up in the side chat an 11-minute video. You only need to watch the first 20 seconds. So when you see it appear, I'll tell you when it's loaded through. When you see it appear, you just watch it, alright?
What?
Just watch the video.
He's going to prove to you that we can bring ships back into view after you think they've gone behind the curve of the Earth. We can
Well,
prove
that
that
can
it's
be
not
very
going
useful
beyond.
to me because I'm a like a navigator. I'm a sailor.
Good. Well, yeah, have a look at the video and we can prove this to you in multiple sources.
There you go. It should be up
So,
now. 2
send
minutes
me
past the hour.
a link on DM.
It's in the
It's in the
side
side
chat.
chat.
In the side chat.
You might have to tag his name.
The music in that video makes the hair stand up on the back of my neck.
So when the video first starts, you see an empty horizon, which is the name of the video, the empty horizon. Then they zoom in, and look at that. Ships appear out of thin air, which I find somewhat interesting because a lot of people claim we're on a ball and ships hide behind or beyond the horizon. If that's true, then it doesn't matter how much zooming you do, you cannot zoom something back that's hidden. But it's interesting that we can zoom in and voila. Ships for
This
all to
is
see.
I watched some of the video. It's just not true.
Well, if it's not true, what did you just watch then?
Dude, I am on ships all the time. I have
I don't really
binoculars,
care.
I have
That's
cameras,
great.
and I like
You're
zoom,
saying it's
like
not true.
it, and
Hey,
I
get good.
don't-
Check it out.
doesn't
You're
happen, like,
saying it's not true. Yep, you're telling us about all the cool things you've got. That is awesome. Nobody cares. You told us it's not true, so if it's not true, you can explain to everyone what the shit you just watched then. If it's not true, what is it?
I don't care what is it. I just have binoculars.
So this is you.
I have
I sail on
have
ship,
built-
therefore fuck you, I'm right. That's what you're saying.
I am on bridges.
Yeah,
That's
his
great.
response is wrong.
With binoculars and high zoom cameras, and that like just doesn't happen. I can see the ship going like behind the curve.
Excellent. So if it doesn't happen with your high-powered cameras, why don't you record it and show us what actually does happen? Instead of just
Ooh.
telling us, nah, you're wrong, why don't you bring the evidence to the table and show us, yeah, you're right.
So get good. Are the dolphins jumping over curvature?
Over curvature?
Are the dolphins jumping over the curvature of the Earth?
What dolphins?
Side
No,
chat.
but sometimes at the bow of my ship, I see the dolphins like swimming in front of us.
Yeah, I posted an animated GIF in the side chat. The dolphins are at about the same location that a ship
Oh.
would be if it were disappearing behind curvature. So my question is, are the dolphins jumping over curvature?
No, this is actually called refraction. Do you see? They are not even on the water; they're on top of it.
My point is that the
This is
horizon
when
is an
the light.
optical phenomenon.
Listen, this is when the light reflects.
Yeah, I
So
agree with you.
So refraction creates a horizon.
Yeah, kind of.
So it's not Earth curve.
No, it. If you look, just 1 second. I'm in a game.
So when is the horizon Earth curve?
Yeah, dude, just look up what refraction is.
I get it. So that's our point. The horizon is an optical phenomenon that you witness that changes with meteorological conditions.
No, I'm saying that you can see things behind Earth's curvature because of the refraction phenomenon.
How would you know there's curvature and refraction?
Just look it up. Like I don't have visual
I know
aids.
what the claim is. I'm asking you for an answer because I know
I don't
what the
have
answer
visual
is.
aids to
There is none.
explain to you. Sorry.
Yeah, there is no
Also,
curvature. So is it refraction that gives a horizon or refraction that makes you see too far or both?
it makes you see behind the Earth's curvature. It
When
makes
does
you
it do
see
that?
things that are above it. It depends.
Are the dolphins behind Earth curvature?
They can be. I'm not sure about the.
Yeah, you're not sure about curvature, are you now?
No, I mean I'm not sure about the GIF, but
Well, yeah, you're also not sure about curvature because you don't have any.
I guess not. I guess the Earth is flat. Shit, you got me.
Yeah, because you want it to be refracted when you see too far, and you want it to be refracted when you see obvious miraging effects. You want refraction to explain away
Oh,
your
this
lack of
is
curvature in both
because, in the
cases.
GIF you're showing me, the dolphins are like when they're jumping, they're not returning to water. If you like look closely,
Oh,
they're
so in real life they
returning
don't, or
to a
do they?
point. They are returning to a point just above the surface of water because
Don't
refraction
be
is making
silly.
you see
Dolphins
them.
swim in the water. They don't hover above the water.
In the image they are. Look at the image you sent me closely.
Yeah, I get it. So that's not curvature.
No, it's it's the refraction you're seeing.
Yeah,
That's what I'm talking about.
that's what happens with boats too.
With boats? Yes,
Yeah, boats do
refraction
the
can
same
also
thing when
happen
they
to
go in the
boats.
distance. Sometimes it looks like they're floating.
Refraction can happen to boats too.
Yeah, I agree.
I
Here's a
see it
lighthouse under
also
different
in
conditions, cold, warm, and hot.
yeah, it also depends on the water vapor or something. I don't
Yeah,
know.
there's no curvature here.
There is, yes. It's
Where
if
is it?
the weather is nice and there's no refraction, you can like see the curvature. I'm just
Well, that's what we're
explaining
after.
the GIF
I want to
you're
see that. I've never seen that before, dude. Nobody else in here
So,
has, and neither of you.
so
have
let me
you
get this
ever been
straight.
on a
Get
boat?
good. Hold on. Get good. Get good. You're just telling us now that this magic refraction is making us see further. So that means on a clear day when there's zero refraction, our optical limit should be reduced.
Yeah.
Interesting.
Same with infrared too, right? Like if I look in infrared, I should see through all the heat haze of the atmosphere. I should see things clearly and undistorted. Therefore, the
I don't
curvature of
know
the Earth
about
should be obvious.
I don't know about infrared. Like I don't know its effect on your vision.
Oh, you don't know anything about infrared. Okay, well, people use infrared because you can see further with it than you can with your own eyes.
Isn't it like it sees or is that thermal vision? I don't know.
Thermal is a form of it, but you can use what's called like near infrared. The 720 to 850 nanometer wavelength range is the Goldilocks zone. So you can get cameras, you can set them to see them in monochrome black and white with an infrared filter. And if you look at the horizon with your own eyes, you just see things fading into the distance. But then you slap on that infrared filter with your camera and you can see beyond where you could with your own eyes. You see the objects that were once obscured by the haze of the atmosphere.
I see.
Yeah.
So I guess my eyes are not working properly and I should get new eyes.
Well, we're saying when we use instruments to look for curvature of the Earth, we can't find it. In this example I'm showing you, the observer was at 35,000 feet in an airplane, approximately,
What is 35,000 feet?
about 10,000
Speak
meters.
to me in kilometers and
Yeah,
like
10,000
metric.
meters.
Yeah.
Okay. The distance to the horizon should be about 500 to 600 kilometers away from that height. But he can see about 1,200 kilometers. Something like that. He can see about twice as far. You know, so I mean, if I don't know, see, what is that going to be? 500 miles is 800 kilometers. So he's seeing 800 kilometers away. And he should be seeing a 400 kilometer curvature of the Earth. He's seeing twice as far as he can with infrared. You can zoom right in. Those are the Rocky Mountains. which are plainly visible and clearly identifiable, because everything between the observer and the Rocky Mountains is desert, flat desert. So we can't find the curvature of the Earth. Nobody can. We've got so many attempts to do this with lasers, with mirror flashes. That's right. You can take a mirror and you can flash the sun at a friend, or have a friend flash the sun at you with a mirror above the surface of water. Direct line of sight. No curve. So what we're trying to find are examples of where this curvature of the Earth is supposed to be. When people say it's well refracted, then what they're saying is yeah, the Earth looks flat. And they're saying my best evidence of a globe is how flat it looks. And the only way I know it's a globe is because it's so flat looking, it has to be refracted. And I know it's refraction because, well, Earth has to be a globe. And anybody who questions or challenges this doesn't know what they're talking about. And when people ask me about it, I don't know what I'm talking about. That's the kind of conversation we have in here all day, every day with people.
And it's clearly a curvature, so I don't know.
Oh, where is it? You know, if there is curvature, then it's not where it should be, which means we also have a problem.
No, dude, it's like everywhere. Like everywhere.
Everywhere.
Very.
So like an ant on a ball, you can't detect it, but you know it's there.
In your sock drawer, down the local fish and chip shop, whereabouts everywhere.
Have you ever been on an airplane and just looked down?
Yeah,
Have you
multiple
ever flown
times.
one?
Yeah, I used to fly for a living for my work, not a pilot.
Good. So you know, so you saw what I'm talking about.
Yeah, I also know that you shouldn't be able to see curvature, even if the Earth is a globe from that height.
What?
Yeah. Which is why we need to use precise measurements and object markers to measure it. It's why we should be able, like, the curvature should not be distinguishable unless you were taking line of sight observations to specific markers in the distance and at known distances or tested distances. You can use the globe calculated distance and test for that. So what do you say about the infrared footage that I showed you from an airplane? Like, I think it's really funny that I spent a few minutes describing an observation with you of an airplane, an observer in an airplane seeing way too far. And then 2 minutes later, you try to rebut me with going up in an airplane.
So is it the video where? Just 1 second.
Because your eyes from any height are incapable of perceiving curvature of the horizon from the left to the right in your field of view, we have to test it in the z-axis, which in this case, for convention's sake, is from your point of observation off in the distance, and looking for evidence of drop over distance that conforms to what the curvature should be. And this approximates to about 8 inches per mile squared. Is that like 13 centimeters per 1.6 kilometers squared?
So you fly planes, so you went to like navigation academy, right?
No, I said I didn't fly a plane. I wasn't a pilot. But I flew for a living. I flew all over the world.
What did you fly if you're not a pilot?
Listen,
Don't
I've
say
been a passenger and I've been in the cockpit of airplanes.
that.
Doesn't
Good,
make me a pilot.
but you said you flew airplanes.
No, I've flown in an airplane. Yes,
You
that's how
flew
you
in
go in
it.
an airplane. You fly in it.
Thought you said you flew it.
No, I asked you if you've ever flown one.
No, I've driven ships.
Stick to what you know.
Yeah. So anyway, sounds like you don't know much about flying, but you're asking us about what we know about flying.
No, it's like you can see it if you look out the window. Didn't you see it when you flew?
No, I never saw the curvature. And when people take their infrared optics, super zoom lenses, as in the case I showed you, to try and look for it, they can't find it either. Do you expect to see curvature to the left and to the right when you look out an airplane window?
I did.
You did. So if you look behind you and you look left and right, you see it curving down to the left and down to the right as well, huh?
What do you mean?
So when you look out in the other direction, you're seeing an arch. And it's just like arches, just humps and humps and humps and humps of curvature in every direction you look. That's what you're telling the audience right now, that it's obvious that you don't know how you're seeing. And you lack complete spatial awareness too. Right, because if I'm looking straight ahead and I see an arch of a horizon, and then I look to my left and I see an arch of a horizon, then if I look between front and between left, should I see where the two arches meet? No, I see another arch. Oh my gosh. But in reality, you don't see this. People claim to see it at the beach, and that's even crazier. People claim that they've been in the International Space Station and they can see the arching curvature of the horizon, and that's still impossible. You have to be able to detect it in the z-axis, going from the observer off into the distance.
That's only about 3% of Earth. You would only see about 3% at that altitude.
What do you study?
What do you study?
Navigation.
Navigation. Oh, really?
Yeah, what about you?
Navigation.
You also study navigation?
Yeah, I do.
So did
Do you
they
know-
give you that problem in navigation where, like, I'll give you a problem in navigation. If you go like 50 miles north, right? And then you go 50 miles west, and then 50 miles south, and then 50 miles east, where would you end up?
It depends what map you're using. Depends
What
what coordinate reference system you're using. Depends what conventions for west and east you're using. Am I going west and east with relative to magnetic north, or west and east relative to the celestial pole north? Am I following rhumb lines west and east, or am I following great circle routes going left and right? Can I actually form a square on a spherical surface? Absolutely not. Let me ask you something.
Well,
how is latitude derived?
Derived? What do you mean derived?
Yeah. What does latitude express? What is it?
It's the way like they mapped the globe.
Listen,
Like
I study navigation, don't you? I'll give you the answer. It's your angle to Polaris in the north, or degrees of declination.
latitude is the
Degrees of
angle to
declination
Polaris?
too. It's also degrees of declination from the celestial equator.
That's what latitude is?
Yeah. I thought you studied navigation.
Well, not this navigation. This is
Oh,
weird.
really? How do you derive longitude?
What do you mean derive?
Yeah, where does longitude come from? How do you determine your longitude?
So longitude is circles from the two poles.
Wrong. It has to do with the sun at your zenith, at your observation,
No, what? No.
subtracted from the prime meridian. And with the cosine of the latitude is derived from rotating 15 degrees per hour. I thought you studied navigation, Get Good. Why do you come in here and lie?
I did, and that's not what they taught us.
Is longitude parallel?
Parallel to... No, it's not.
Okay, is latitude parallel?
Yes.
So what you describe with latitude and longitude is a spherical surface.
Mm.
It's a spherical coordinate reference system.
Yes.
And there are 2 points of origin. One point of origin is associated with the north, where the lines of longitude meet, and the other is where the lines of longitude meet in the south. It's just a mathematical construct.
Yeah.
Right. It was
It's
formed
like...
out of the celestial sphere model, which is not something that exists in physical reality.
Well, how does it not exist in physical reality if it works with me all the time?
Because it is a coordinate reference system. It's not a real thing. It was formed out of a concept of the stars.
Well, how is it not real if it just works? Like, I made trips according to these maps, like...
Yeah.
And
Yeah,
they...
something can
I
work and
arrived
be...
on where I wanted to go, so I don't understand, like, how is it wrong?
Listen,
real
what you build is a
questions like
model, okay? And just because a model can work up to a certain point within a certain tolerance for error doesn't mean that it's true.
No, I'm not talking about models. I'm talking about I've driven real ships according to these maps, and I got to where I wanted to go.
I know. I'm telling you, the
Exactly where I
map is
wanted to go.
a model, is a conceptual model, dude. The map that you apply, you have not measured actual distances with your ship.
How did I not
That's a fact.
measure? Just 1 second, I'm in game. Fucking
You
died. Yeah.
calculate distances on the map that correspond
Yes.
to where you believe your position is with the ship. You haven't
So
used your ship itself
wait.
to actually measure distances.
I know my speed, right?
How do you know your speed? How do you know that that is
On
accurate?
the
To what degree?
I know what the engine does. Like, I know its capacity. I know my speed. Dude, I just know what my speed is.
Oh yeah, so when
And
you're
I
going
know
against the
what time
current,
I departed and what time I arrived. So I know the time of the voyage.
oh, so how do you know where you are to know the distance that you went?
I look at
You
the
use the
fucking
map, right? You're gauging in circular logic. So you say I started at this coordinate here, I end at that coordinate there on the map,
Mm-hmm.
and it took me 4 hours to get from here to there.
With this
And you
speed.
calculate your speed, but that's not a measurement,
No, I
dude.
don't
You're just
calculate
using
my
map
speed.
calculated distances.
Dude, I know my speed. I know my
You
time.
really don't know your
All
speed.
what's left you can do is you can get distance from that.
Okay, so how do you know if you're heading into a 4-knot current versus an 8-knot current?
There's like a... Just 1 second.
Well, I mean, you typically use GPS, right? That's super high resolution, and it calculates your distance on the coordinate reference system.
No,
you
we use
discover that you need
there's
to
like this
increase your power a certain
device.
amount in order to keep up the same velocity that you'd maintained earlier.
No, just 1 second. There's this device called Navtex. It like gives us regular weather updates on certain areas. So and including current and wind and stuff like that. So we add it to calculation and we get the we get the correction for the course we're taking according to that.
Yeah, but it's not measured is the point.
How is it not measured? I'm just telling you that
Yeah.
there is current that comes like there is a like for an example southwest 3 miles per hour current in some place, and it's like pushing against us. So we like and
How do
it's
you know
like
you're slowing down?
pushing us to the right. So we expect our course to be a little to the right.
Yeah, but you don't know, you're not measuring by how much exactly you're calculating. It's based off of estimation.
Yeah, no, we do measure. We do measure exactly where we should be, and it's all the time. It's right every
You're
single time.
describing calculations and estimates.
No,
You're
no,
describing
I'm telling you, we
statistical
have
sampling from weather data.
like we have data and we apply it to equations and we get results that we can apply it to reality, and it's
Oh,
exactly that.
exactly. Like I said, you're calculating, you're using equations and statistical estimates.
Yes, we do
That's
that.
not a measurement.
Yes, it is. What is a measurement, dude?
Yeah, that's probably where we should start with this whole conversation. What is a measurement?
If not that, like, if the map says that there is a port on this particular place, and then I go to this place on the map and I see a port, then what's wrong? What's like the wrong thing you're describing here?
Well, it depends. You know, it's going to be the distance is going to be wrong, because if you're using a spherical coordinate reference system over a terrain, over water that's measurably flat, then your coordinate reference system, without any kinds of corrections, is not giving you the true distance. That's a geometric truth. It's proven by Carl Gauss. I can cite this. Hold on.
I
All right, side check.
yeah.
Relying on experience or observation, often without due regard for system and theory.
Yep, that's what I said. Primary source knowledge from sensory experience, measurement, direct experience, measurement, experimentation, touch.
But see, if science that is based on the fact that the Earth is a globe is like wrong, and I use that science and I get results every single time, like how does that make it like not?
Because you don't know what science is.
I
You
guess
don't
not.
understand what the definition of science is. Science is empirical, using empirical data to identify the cause of a phenomenon. So the scientific method is a method of using empirical data to prove the cause of something. Now you can't do that with the globe. So your statement is wrong.
So
You
you're
can't
saying
use
that wait, so you're saying that using like evidence that are based on things that we experience is like not a good thing or something?
No, I'm saying to prove your globe, you can't use empirical, first-hand, direct evidence. You have to use philosophy and belief. So you
Oh,
think
so it's kind of like a religion.
Like a religion, exactly. So I want to ask you, if you disagree with me, I want you to tell me what science you can use to prove the Earth is a ball?
What science do I use to? Yes, the
Yeah,
science of looking.
there is no science of looking. That's
Yeah,
called
I look at
observation.
things and they disappear behind the horizon. They
Right, but
disappear
that's
like ships disappear hull first. Hull is like the bottom part.
so is that science to you?
Yes, it
No,
happened
you're
to
wrong.
me and it works
You're
every
wrong.
single time, so
No,
it's like
no,
a science.
you're wrong.
Typically right.
Observation alone is not science. Observation is observation. It is the first step in the scientific method. There are 5 other steps that you need to complete before you can call this science. So that's step 1, observation of a scientific inquiry. But without a scientific experiment, you're not doing science.
Yeah, you can't just
So
observe
science
the
is
ships
more
going
than
hull first and then come to the conclusion that it's because of Earth curve. That would be fallacious. That would be of not sound reason to just assume that something is the cause of something. Correct?
so like inputting the same data through a like an equation over and over again and getting the same results in theory and in real life is not like good enough evidence.
No, that's not what you put forth. You put forth an observation of the whole of a ship disappearing from Earth curvature because you observed the whole of the ship getting obscured first, right?
Yes, that's the data.
So you made an observation and then you presumed the cause.
The
That is
result
not of
is
sound
the
reason.
ship going like down every single time.
So you're observing it and then you're presuming the cause. Don't you see that? Come on.
That's called confirmation bias. It's a logical fallacy. You're appealing to the observation as some sort of proof for something, but you could be wrong. Because, for example, the ship going over the horizon can easily be brought back into view, there or thereabouts, with a high-powered zoom lens. So you haven't proven that the ship is disappearing due to a physical obstruction of Earth curve, because we can show you examples where that doesn't happen. So this couldn't be considered science. This is a speculation that you have come to due to confirmation bias. You've been told it's due to the curve of the Earth, but in actuality, you haven't tested that.
And we're not
It's a
trying to attack
logical
your,
fallacy.
yes. And we're not trying to attack your ego or call you stupid. Like I did the same thing before I actually thought about, wait a minute, that isn't of sound reason. I am just presuming this. I am just being fallacious. I did the same thing. So the silence after we tell you, you know, this is not of sound reason, and then I can hear the gears turning in your head. And don't let your ego get in the way of you admitting, yeah, you guys are actually correct. Because this isn't like we're not trying to call you stupid or anything like that. Like many globe defenders call us, but then when we call them out on their fallacious reasoning, they crash out. You know what I mean?
Yes, just the silence is because I'm playing Dora 2.
So you're not actually registering what we are saying and agreeing that presuming the causation of something is not scientific.
I mean,
What did you say?
if something goes down, isn't that evidence that the thing that it's like on is going down as well?
It is. It may be, you know, it could be evidence, but it requires further inquiry. You can't just make an observation and say, this is why it's happening, and not prove it in a logical sense. You can't just see something happen and say, this reason is why this is happening. This is why we're observing it, and then end it there.
Get good. I have a
inflation.
question. In the side chat, I posted an animated image. Is the candle sinking?
What candle? Just 1 second.
It's in the side chat.
Yes, the candle's going down.
Is that your final answer?
Yes, it looks like it's going down.
Please look at it again.
In the top GIF, the candle looks like it's going down. Yeah. The bottom one, it's like a slope or something, and the camera, it's an angle or some shit.
It's not at an angle. It has a piece of material between it that affects.
Yeah. What is that?
I'm not sure. Some kind of lens.
The bottom picture.
I would like to get one. That would be cool to make the same, replicate it.
Called a Fresnel lens.
Yeah.
Yes.
Anyway, back
Yes.
to you.
What's in the bottom picture? Like, I did not understand the bottom picture yet.
It's the same setup.
Yeah, I know, but how is this square thing affecting making the candle go down?
I know, it's trippy, right?
Yeah.
But this exists. And then we discussed earlier how the horizon is optical.
Yes, but
You keep bringing up ships
what's
sinking, and I'm
happening in
just
the
saying.
square? No, you didn't tell me what's happening in the square. Like, I still don't understand.
It's optical phenomenon. Like, clearly the candle's not actually
Yeah,
sinking.
how is it being caused by this piece of paper that's in front of the camera in the bottom picture?
And I think Amphibious already answered that.
Or what did he say?
I think somebody said a Fresnel lens.
Yeah, it's a Fresnel lens is what that lens is called.
Resident lens, what?
A Fresnel, Fresnal.
What does that mean?
That's what that is. That's in between the camera and the candle. Right? And then that Fresnel lens, why it's there is to simulate the atmosphere.
Yes, but what it is, wait, I need to Google it. I don't understand what that is.
It's just a type of lens, right? It kind of distorts what you're seeing, right? Same as the air distorts what you're seeing, right? So it's just a way to show what we see over long distances on a short distance.
My point in sharing that is that this type of optical phenomenon exists. I'm going to mute up and pass the mic back to Amphibious. He was doing great.
Amphibious, you got anything to say?
Concentric grooves instead of a continuous surface. Yeah, okay, but how is that like a ship going down?
Well, it's the whole point of it is a demonstration of an object.
Oh, so you're trying to tell me that
when it
looking at
appears,
something doesn't mean that
disappear
it's
from the
true?
bottom first. I was trying to explain it to you if you don't want to talk over me, right? So the object is the candle is similar to like a boat, right?
Mm-hmm.
And as they move the candle away on the flat surface, it appears to disappear from the bottom first,
Yep.
right? So the condition of it appearing to disappear from the bottom first is not due to curvature.
Yeah.
And so the whole point of this demonstration is to show that this effect can happen without
It's due to the
having a
lens.
smooth surface.
Yeah, that's cool, but I don't see if like we don't use lenses in the ship's bridges that I work on.
Right, that's fair, but also this is only across a 3-foot table or 4-foot table, right? When you're looking across boats over the ocean, you're looking across miles,
So, just 1 second.
right? So the effect of the Fresnel lens is to magnify the effect, right? To increase the magnitude of the effect over a short distance, so we can demonstrate, right? And we know that
So you're
table's flat,
saying what the
so we know that the effect can happen on a flat surface.
so you're saying that the effect that the forensic lens makes
Fresnel lens,
like
yeah.
happens naturally over large distances?
Yeah, well, that's what we observe, right? Right, when people say boats disappear over the curvature of the horizon, right? Heard that saying before? Yes? Hello? You good?
He's choking down his tears.
Just 1 second, my net is not good.
Yeah, no worries, my friend.
Yeah, earlier he had. Go ahead.
Take your time, man. I want you to take all the time to digest this.
My hope is that he's actually digesting it and not playing the video game that he was saying he was distracted by. Because why else would you come in here to not, actually try and learn? There's a lot of people that come in here and they just want to reaffirm their bias. And then when they come to the conclusion that they are being, of not sound reason, they either leave, get emotional, and they don't learn. But I guess that's part of the process, right?
Yeah, it's tough to realize you don't have sound reason when you've never really been taught what reason is.
Exactly.
Yeah, my internet just like I switched to a different network. What were you saying?
I was saying the Fresnel lens, right? It
So
demonstrates that we can see a distant object over a flat surface disappear from the bottom up, right? So when we're out in nature and we look over at a boat and we say it disappears due to the curvature of the horizon, that's actually a fallacy. It's called begging the question, right? You're assuming that there's an effect happening due to a certain condition, right? And that condition hasn't been measured, it hasn't been established.
Sorry, I got Tourette
so
syndrome.
the way so I think that neglects the way the forensic lens manipulates how you see the candle.
Yeah, it kind of increases the effect, similar effect that you'd see with air,
Oh,
right?
so
Air
it does
air
the
has
same
a
thing.
magnifying effect, right? It can distort what you see. You see things blurry sometimes, right? Through the air.
Yeah, in
Right?
the when
Same thing.
refraction happens, you also don't see what really
Whoa,
is
whoa, whoa,
happening.
whoa, whoa, whoa!
Uh-oh.
Whoa, brother.
Word.
Whoa.
You figured AI. You
So
got him.
if
Got him going.
refraction happens, then that means light's being redirected, right?
Yep.
Okay, fair enough. So if that's true, here's the facts of reality. The facts of reality are that we can see boats 30 miles away when they should be buried below 400 feet of Earth curvature. Hold on. Hey, friend. I'm not done with my sentence. Thanks. I'm not going to be gracious and allow you to interrupt me. Okay? It's not going to
Let him
happen.
get his point out, and then he can share with you any related information if you want to verify what he's saying.
So we can see boats 30 miles away. Should be buried below 400 feet of Earth curvature. We can also see boats disappear from the bottom 1,000 feet away. Now, the problem is, in both instances, that supersedes globe geometry. Either it's disappearing too close where the horizon wouldn't even exist yet, according to globe geometry, or you can see it way further than the geometry of the Earth would allow. Now, if that's true, and it is, then all the effects that we see are in the category of optical phenomenon. So you can't just say, I can't see the bottom of something, therefore the Earth's a globe. You have to prove the underlying geometry. So what say you? Do you have any proof of that underlying geometry?
I have a question. Okay, what
Yeah, there already is.
who
Hold on. There already is a question. There already is a question.
who have
Hey,
what?
hey, man 87, man 87. Somebody already asked a question. It's on the table right now. The person who's supposed to reply isn't you. So you don't get
Okay,
to butt in and say, I have a different question. So just wait your turn, okay?
I'm sorry. I'm sorry.
Dude, he's 7.
No worries.
So what are you talking about here?
So real quick, Grimm showed that things can disappear without curvature of an object. I demonstrated that curvature of an object is superseded by observations, allegedly a claim to the curvature size. You could see things disappear closer and further than the alleged curvature would be in the way. So now we have categorical proof that what we're witnessing is in the category of an optical phenomenon, which we all know. And so in order to claim that this is proof of a globe, you have to have proof of the underlying geometry of the globe. So the question on the table is, do you have any proof of the underlying geometry of the globe is the cause and the sole cause for this phenomenon for you to say that this happens, therefore globe? Go ahead. All right, silence is acquiescence, so let it be written, so let it be done. Things disappear out in the distance due to optics, not because the Earth is a globe. That question is closed. So man 87, it's up to you now. What's your question? Oh, he left. But yeah, get good. What do you have to say about that?
About what?
I don't know. Were you listening?
Yes, you were saying something about like every instance of sight is just optical. It's not like a proof of anything.
That's not what I said. But that's I mean that you could boil it down to just because you see something and make geometric assumptions about it doesn't mean your geometric assumptions are correct. So you'd have to prove your
Or
geometry.
basically, you're saying that if I see something, it's not true.
No.
Okay. I
If
think
you see
there's
something and then you make claims beyond what you see, right?
so I'm looking at
Assumptions and
a laptop
and
right
logical
now,
inferences.
and it's
Go
just
ahead.
not clear, right?
No, see, I have no idea what you just asked me because you were talking when I was talking. So I'm going to stop talking. Go ahead and ask your question.
Yeah, so I'm looking at a laptop right now, so it doesn't have to be like, it doesn't have to exist. Like,
Okay, so you're reducing what I said to science. Nobody ever said anything like that. What you're doing, sir, is you're coping with reality. Okay? Nobody said anything that stupid, okay? Nobody. Except you. You posited the idea that if I see a laptop, it's not a laptop. No, dude, that's not what nobody's saying.
No, you need.
We're
You're
saying
saying that I need to give you scientific evidence and proof that I'm looking at a laptop when it's just a
no,
laptop.
not at all, not at all, not at all. So, for example, if you look at a laptop and you could tell by its form that it's clearly a laptop, that doesn't tell you what brand it is. That doesn't tell you what processor it has. So you might say, oh, there's a laptop, therefore it has a GTX 7080 inside. Well, no, you wouldn't possibly know that. Maybe it doesn't have one of those. So the assumption that it has a certain graphics card inside would have to be proved separately from saying this is clearly a laptop.
But I can tell it's a laptop without like knowing what its processor is.
Exactly. So when you make a claim about it being a laptop, that is true. When you make a claim about what processor it has, that could be true, but it's not necessarily true. So, for example, you look out into the world and you see, oh, I can't see that boat. And that's true. I can't see the boat. That's true. Then you say, I can't see the boat because the earth is a curve. Well, that could be true, but just because you can't see the boat doesn't mean that that is true.
But in this case, like looking at the laptop is all I need to prove that it is indeed a laptop. So.
I know we agreed. We agreed that if a laptop is a laptop and you identify a laptop, it's a laptop. We all agree with that.
Yeah, so now
tell me how understanding that a laptop is a laptop means the Earth is a globe.
Yes, so I'm seeing something go down when it like goes off in the distance. So like it's just
No, not necessarily. No. See, you're messing up, dude.
Like all
you're
you
already
need
messing up.
to verify that is to look. Like I don't
exactly,
know
exactly, exactly.
how far it is or anything.
Okay, so tell me this, friend. Is the only reason available in reality that things go down in your field of view is because Earth is a globe? Is that the only reason?
Well, that's the most obvious one that doesn't need to go through like scientific shit to prove it.
No, dude. See, that's the problem. You're just making a claim that that's the only one that you don't have to go through scientific. Things go down in your field of view due to perspective alone. Things can go down in your field of view due to refractive effects. So you're wrong, sir. You're just wrong. There's three options on the table of many. So you have globe, you have redirection of light, and you have perspective effects. There's three. That's three. So it's not just one cause. You can't just look at something and say, I can't see it, therefore globe. You can't just look at something and say it's going down, therefore globe. Now, I can prove you're wrong. Listen, I can prove you're wrong, bro. Go ahead.
Yeah. So if I look at something and that something is not moving, I can't say it's not moving because I can't scientifically prove it.
Dude, why are you talking about things that aren't the point?
No, I'm trying to like say what you're saying, but in like simpler terms. Because like that's what I'm understanding when you say the things that you're saying.
Well, listen, dude. A car. You see a car, and it's clearly moving along the road.
Yeah.
And it's moving down the road.
Mm-hmm.
You have no way of knowing from just seeing the car moving whether the guy in the car is actually pressing the gas pedal or not. He could be coasting. And you also don't know whether it's an electric car, a gas combustion car, or some other type of fuel. It could be a kerosene engine for all you know.
Yes, sorry,
None
but
of that
that's the information I'm looking
car moving.
for. Like this is not what I'm looking for when I'm making Like, this is not the information I'm taking from that. All I want to know is this car moving or not? That's all the information I want.
Correct. So a car moving is a car moving. So when you look out and you see, I can't see the boat, you see, instead of seeing the car moving, you see a globe. That's the problem.
Yeah, so look, if I ever see a car and that car goes down a slope and it disappears from like the bottom all the way up, and then I see a ship doing the same thing, I'll just like assume that this is what's happening here.
Correct, sir. Correct. I'll agree with you. Get good. I will agree with you that you will assume that. Now, assuming something is not the same as it being the case. It's not the same as it being true.
Well, if every object behaves that way when it does this, like when it goes far from you, then how is it not the case on that particular instance?
Look, it's not whether it is or isn't the case. It's whether the observation itself validates it's the case. Because there is, like I told you, multiple factors that can cause things to disappear out in the distance. And not only that, but if you claim it's Earth curvature as the sole cause, well, I have a lake that's only 1,000 feet long where I could see things disappear. Now, there's a huge implication for your view there, because according to you, that's disappearing because of the curvature. But there is no curvature significant enough within 1,000 feet to occlude a boat, to make a boat disappear. So your claim that it's the Earth curve causing this phenomenon only is just false. It's demonstrably false.
Yeah, see, I'm a maritime officer, so my job is to
It doesn't matter.
look at no wait. My job is to look at ships while they're going down. So, and I have on the bridge of my ship like high power telescopes and things. So
Dude, that's not your job. There's no
yeah,
such job as look at ships going down.
it is a part of the job, yes. Anyways,
For what purpose? Okay, great. For what purpose do you look at ships going down? What purpose does it serve your job?
well, so I know if they're like I observe the movement of ships around me to determine if it's like a to determine if there's ever a risk of collision or something.
Right.
Anyway,
Okay,
so
but you didn't tell me why the ships going down are relevant to that task.
no, it's not. I do it for fun, but I just
Oh, see, so it's not actually part of your job at all. Good job. Told on yourself.
Hey, quit yelling. It's against server rules to be yelling and interrupting people, all right? Don't make me report you again. Just chill. Chill, brother. Let him speak. All right? You don't gotta do this.
Yeah.
Hey, Ozzy.
Watch your blood pressure.
Watch your blood pressure, bro. Nobody's yelling, okay?
Look, it's not your job.
I'm pretty sure you
All right, dude, get muted. There you go, Ozzy. Go report me, bro.
Didn't this guy just like yell 10 seconds ago?
Look, escalating your voice is not the same as yelling at someone. But whatever. he was probably raised by two single moms or something.
Raising your voice is like yelling. Yeah, it is. Anyways, no, I don't care if you're yelling or not. I'm just saying that, like, I'm a officer, so I see ships go down all.
Seeing ships go down, which we already all agree. We all agree that you can look out and see ships go down sometimes. We agree with that. Nothing wrong with that.
What do you
For
think
example,
the cause is?
I see ships disappearing on my 1,000-foot lake. Other
Like I see, were you listening? 1 second. So when I leave port, right? I look behind me. I also see big cities disappear.
Yeah, we all agree with that. Yeah, we
there's like
do.
a mountain.
Listen, that's
I
not for
still see the
contention.
top, and I don't see the city. That means
Okay,
that
no duh.
the mountain is behind something.
No, it
The
doesn't.
mountain bottom is behind something. Now, what
Why
is
does
this
it mean
something?
that? Why does it mean that? No, hold on, Fred. You
Well,
said
because
if
I
I
can't
can't
see
see
it.
something, that means it's behind something. Now prove
Yes,
that.
I'm telling you because there's sea between me and like the middle part of the mountain.
How do you know that? How do you know that?
I looked and that's what I saw, dude.
No, that's not what you saw.
No, it is. Yes, that is
No,
what
it
I
isn't. No, it is. See, listen, friend, whether you realize it or not, see, I'm actually a fully credentialed art teacher, and we actually teach kids how to draw, and we teach them
Okay.
how to interpret what they see and put it into a two-dimensional piece of paper, okay? And so we
Perfect.
do this exercise, and this exercise is called draw what you see, not what you know. So when you actually look out, you don't see something in between something. You just see a portion of your field of view filled with the color of the water, and then above that color of the water, you see a portion of your field of view filled with colors that belong to the building. So you interpret that as a hump of water in between you and the object. However, you don't actually see a hump. You never
Um,
see a hump.
I do because it happens slowly. See, like
No,
the
no, no, no. See, dude, you're just telling me the exact same thing I said, but you said now it happens over a longer period of time. That's not the same as seeing a hump, dude.
yes, it
You
is.
infer, you assume, you are, listen, I want you to be honest with yourself. You are inferring a hump. Yes or no?
No, I'm looking at a hump as it is
Okay,
slowly like
dude, your credibility
rising
shot.
and
Your
covering
credibility shot, brother.
like covering the city, and then it covers the middle of the mountain, and then it covers the top, and then I'm like
Don't
there.
care. Don't care, dude, you already earlier said that you're assuming it's curved. Now you're saying you're seeing that it's curved. So which is it?
I mean, I'm looking, and this is what's happening. This is
Yes,
what
you're
I'm seeing.
describing that the field of view that you have, more of your field of view is being covered in color of water, right? You're not actually telling me that you're seeing a hump. Whether you realize it or not, you're inferring a hump. Now, I know that's true. Everybody with an intelligent way of thinking about spatial reality and understands logic understands that you're inferring it. You're just denying that you're inferring it. You're looking out,
Not
seeing something
inferring
disappear, and
it.
saying, "I see a hump." There's no hump that you're seeing, dude. None.
What does inferring mean?
Inferring is kind of like assuming.
Oh,
But inferring, listen,
so
assuming you could just do, hold on, friend. Assuming you could just do out of thin air, like you could just assume something for no reason. Inferring is you're making an assumption based on a line of reasoning. So it's not unreasonable for you to say that, but you are inferring it.
So I need to scientifically prove to you that what I saw is is that what I saw is true or something?
No, listen. We both agree on what you actually saw.
Okay,
Okay?
cool.
What you
But
saw.
we said like
Hold
a
on, brother.
few
Hold on.
minutes ago that if I'm looking at a car and what I want is the information of whether it is moving or not, looking is all what matters. And I'm telling you what
Right.
I see when I look.
Right,
That's what
right,
really
right.
matters.
So you're correct. So you're messing up because you tell me that when I go away from the city and I look back, the city slowly disappears and recedes in my field of view downwards,
Yep.
and the water slowly, maintains its horizontal level, and it seems like to me that the color field of the water, which is below my field of view midline, and the color field of the city is going down. Now, that is true. That's what you're seeing. Now, what you're not seeing is a hump. You're inferring that the cause of what you're seeing is a hump. You're not seeing a hump with your eyes.
Then are you suggesting that the city is below an elevator and the elevator is like going down?
No, what I'm suggesting is that it's an optical effect because it has to be.
What do you mean has to be? Do you not like believe your eyes when you see things?
No, see, I actually believe my eyes, and I don't make up stories about a giant globe being in between me and the city.
Then what conclusion do you come up with when you like see a mountain going down as you move away from it?
Oh, friend, what conclusion do I come up with when I see a boat disappear on my 1,000-foot long lake?
Yes, what conclusion do you make of that?
Well, let's see. If I take what you say is true, that it must be because a globe Earth is in the way. In order for the boat that I'm witnessing, which is a kayak, which is approximately 12 inches tall from the top to the bottom, it's yellow. It's on the pier on the other side of the lake. When that disappears, I could make the assumption, oh, it must be a globe. And then I do the math based on my observer location to the apex of the hump of the curve that would have to be there to block that boat. And that makes the Earth like 1/24th the size that you claim it is. So if it's true that it's the curve of the Earth causing that effect, then that means the Earth is 24 times smaller.
Okay, so maybe something else happened in your case. What was it?
Or what
How
happens in
didn't
every
you see
case,
the boat then, your kayak?
dude. Okay, listen. If it's not physical geometry causing it, there's only one thing left. What is it?
No, I'm talking about that specific case where you couldn't see your
Right.
kayak,
Okay. So
your
if
yellow.
there's if there's no physical geometry in between me and the boat, what must be causing it?
If there's no what?
There's no physical geometry blocking the boat in between me and the boat. So I can't see the boat. So something's causing me not to see it. It's in a category. What category is it in? I'll help you out. It's in the optical category.
What? Dude, what?
Yeah. So you see things with optics and light. That's how you see. And so if something isn't being directly obstructed by geometry, but you can't see it, then it's either dark out or there's an optical effect going on.
Cool. So what's the optical effect you got from your yellow boat? So what happened in that case?
Dude, I don't need to know.
Why don't I think it's weird that you looked at your boat and in a short distance it just disappeared completely. Is that what you're saying, right? That's what you're saying happened to you?
Yeah, that is what happens.
Yeah, well, that's weird. How then what's the case then? Why did that
It's
happen?
not weird. It's not weird at all, dude. It's
is.
not weird to me. It's only weird to you because you have this worldview that things disappear because of Earth curvature. Not weird to me at all.
I don't know. Maybe if I saw the boat, I would have knew what was going on there.
Well, hang out long enough. I'll show them to you. Maybe not today.
You have a picture of your boat?
Oh yeah, I got pictures of the boat.
Like disappearing
and,
in a short distance?
Yeah, dude, it's attached to the pier on the other side of the lake. So I arrive at the lake various times during the year, and I stand at the other shore, which is approximately 1,000 feet away. It's a little longer than 1,000 feet. It's approximately 333 meters. And then I stand to put my feet in the water, and then I lower myself down. And while I'm standing up tall, I can see the boat clearly. And as I lower myself down, it begins to disappear.
Why is that happening?
Because of optics.
Oh, cool.
Because there's limitations. There's limitations to optics. There's current ambient conditions in the weather and the air and the temperature. All these things in coordination together make the boat disappear. Now, here's what's weird. Some days it disappears sideways. Some days it disappears top to bottom. Some days it disappears bottom to top. Some days when I lower myself, the boat actually is yellow, but it turns blue right before it disappears. It turns blue for some reason.
That's interesting.
Now, one of the theories of why it turns blue, one of my friends pointed out, is that on the shore in the background, there's some blue barrels.
So the light is
And
reflecting off of them or something?
yes, yeah. So check this out. This is interesting. Not a lot of people know this, but mirrors are reflective. Everybody knows that. But in actuality, at a certain angle, all surfaces are reflective. And in fact, almost all surfaces are reflecting the colors that don't belong to the color of the object, right? So, for example, yellow is made by absorbing yellow but reflecting all other colors. And so at different angles, you get different colors of light being reflected. So at a certain angle, the boat is actually reflecting more blue than it is other colors. And so when you see it at that angle, you see it as blue.
Oh, yeah, that's a great, like, that could be true, yes. I think you're right.
Now, what's interesting is that can actually be affected by fog, mist, dense air
Yes,
at low altitudes.
it happens like with mist and shit. Yeah, I know what you're talking about, yeah.
Yeah, you can get that with where it looks like a boat is floating in midair, but that's because the water underneath it is reflecting more of the sky than it is the color of
Exactly,
itself.
that's the refraction I was talking about. We get that all the time. It looks like the ship in front of you is like floating on nothing.
Right, and that's because the critical angle of the water is below its ability to send you the colors of itself versus the colors of the sky. So the thing is, brother, here's my problem. People claim that the Earth is a certain size, and then they claim that boats disappear because of the Earth being this size. But I could see boats disappear much sooner than they predict, and I've seen boats much further than they predict. So if it's the Earth curve causing this phenomenon, the only way for that to be true in all instances is if the Earth is changing size. So this doesn't make sense.
Well, maybe this optical illusion things you're talking about,
My mom
like we can
told me
explain
that
these two phenomena
drink
of
water.
like seeing things further. We call it refraction, and seeing things like closer, we call it like a weird light reflection, right?
Okay, let's say that's true.
So when neither of these things are happening, then then there is no like optical illusion happening there. Maybe what you're saying is actually correct.
Right, so then that means that the sole cause of things disappearing or being seen or being blocked is not because of the Earth being curved. So the Earth being curved has to be proven separately.
No, that means when you prove that these two things that make that thing wrong, when you know what they are, then in the default state of things, that is no illusions at all, then what you're saying is correct.
Oh, so you're trying to say that if there's no illusions happening and I can't see the bottom of something, therefore the Earth must be curved.
No, when no illusions are happening, that means your sight is the only source of information you need to verify something. When no illusions are happening.
Wow.
Yeah, I think we got to like a middle ground in that.
Okay, so then put it like this, brother. Show me a raw geometry picture of the Earth from an observer's standpoint that demonstrates it's a globe.
Sorry, what do you mean raw geometry?
Where all the geometry is preserved.
Oh, you mean no? Any picture ever is like a reservation.
No, it's not true. It's not true, dude. Pictures are projective geometry, dude. They're
But
projective.
no,
They're not raw geometry.
Yes, they are, but the scale is different. So I
No,
need
they're
to
not,
show you.
dude.
No, the
Listen, friend.
scale
If
is
if
different.
if a picture, listen, friend, it's so obvious, dude. If a photograph is raw geometry, and when you look at the photo, it looks like the ocean is at the midline of your vision, but you're standing at the beach, then that would mean that the ocean actually ramps up. But it doesn't. The only reason it looks like it's ramping up is because of perspective effects. So it is not raw geometry, dude.
I don't think I understand what you really mean in like geometry. Like geometry, you mean like the way, like the terrain, right? Like a preserved terrain or something? Is that what you mean?
Well, listen, have you ever seen a blueprint?
Yeah.
Okay, so a blueprint is a side view or a
Top
top
view.
down view, right? Either way, could be side or top, could have both, right? That's just lines which preserve their size, proportion, and angle, right? Okay, no, there is no photograph in existence that does that.
Maybe, well, there is, but you need to like zoom out a lot further back. Oh, there
No, no,
is.
no,
Yes,
dude.
actually,
There's none.
there are
There's
a
no
bunch of
photograph that does that.
no, there are a bunch of pictures from like space stations and things that show you exactly that.
What space station?
Like any picture taken from a like a celestial object. Like we send things to space all the time, and some of these have cameras, and you can like look at them. Like there's a lot of pictures.
Really, that's great. So, you're trying to say that these far-reaching craft have taken pictures of the Earth?
Yeah. Yeah, I think I
Really?
have
Okay,
pictures
that's great.
I think I have
Yeah, go
pictures where
ahead. Go
I
ahead
go
and
on
post.
screen.
Yeah, go ahead and post a validatable photograph of the Earth from space, of the whole Earth. Go ahead.
Now, I mean, I'm playing a video game right now. I think maybe I will after when I'm done.
Well, listen, we all know the answer is you can't do it.
There's a bunch of no, there's a bunch of pictures.
Yeah, we all agree there's pictures and images. Nobody disagrees with that.
Cool.
But a picture isn't a photograph, and an image isn't a photograph necessarily.
What? Oh, you mean
And even if it was, listen, even if it was a real photograph, real photographs have to be taken through lenses. And so just because you think you're seeing what you're seeing is the geometry correct, that doesn't mean it's correct. So for example, there's all kinds of images taken with cameras that add curvature distortion to the image. So that curvature distortion doesn't exist in reality.
Nope.
So basically what we're left with, dude, is you have no direct evidence of the surface being curved. You have an inference from things disappearing, and then you have a reliance on alleged images that are alleged to be images of the Earth, which you can't validate to be true because you have no cross-reference material to reference the Earth as being correctly taken from that location. So these are invalidatable, dude.
I think there's a bunch of images from credible sources that are from space, like from different.
How do you know they're How do you know it's credible, dude?
I mean, why? I don't understand. Like, do I need? I don't know what you.
Okay, well, so for example, if I showed you a picture of Bigfoot, how would you validate that it's true or not true?
Probably not, because I've never experienced a Bigfoot. Like, I've never seen a Bigfoot before. But,
Okay, great. Great. Let's agree. Let's agree together that that would be a good standard. You know what you've never experienced before is the Earth as a ball from space. So, by the same way that you can't validate Bigfoot because you have no experience of it, you can't validate any of these images as actually being the Earth because the only time you've ever seen the Earth from space is on TV or in a book.
yeah, so you're saying no image is ever proof of anything.
Guess what? No scientific journal accepts photographs as sole evidence of something. Did you know that?
No.
Well, now you know. So a picture of something is not proof in itself necessarily.
So you're saying all pictures are fake?
Who said that, dude?
You said all pictures of.
No. No, I said they're not necessarily proof in themselves of a thing.
Okay, I guess. I mean, yes, sure, especially in now times with AI and shit, you can like create all kinds
Right.
of
Hey, yeah,
images
fair enough.
that
Fair enough, brother. But you don't need AI to make fake images. In fact,
yeah,
you
you
can
can do.
make images with photo editing software. And you know what, dude? Before photo editing software existed, they used to make fake photos in the dark room. They would take film and they would edit the film physically inside the development room. In fact, I think the first forged photograph was like 200 years ago or something.
Yep, that can happen.
They used to make photos
Just
of
1
people. It was
second,
a
I need to
common.
switch network.
All right, cool.
Terrible. Can you hear me?
Yeah, brother. So I was saying before you left is they used to have this cultural fad back in the day where people would take photos of themselves holding their own head. So what they would do is they would take an image of themselves and then they would take another image of themselves, and the way that they would do it with a long exposure, it would make it look like they were headless and their head was in their hand. And that was like a cool
Yeah.
photo people used to do.
Yeah, it's like the Instagram filter or something.
Yeah, they used to do that. They did that way before software existed. They did it with the physical camera.
Yeah, they also can like you can like fake something by like acting it. Like you can hold a dead person's corpse like it's alive and like fake that it's alive. It's funny. They also used to do that. Like the last
Right,
picture
or
people used to take of their loved one is like
yeah,
they hold them up as if they're alive and they take the picture and it's fucking retarded.
yeah. Know what else you can do? You can take maps, right? And then you could take images of weather data from the National Oceanic Association, and then you can overlay them on a 3D model made by Robert Simmons, a graphic designer from NASA, and you can then post process it and then claim that it's a image of the Earth taken from a satellite every 10 minutes.
Cool, yeah, you can do that.
I know you
But
can. They do that. It's called the Himawari 8 satellite. That's what
the
that
what?
device does. The Himawari 8 does exactly what I just told you. And they got
Himawari
busted.
8?
Yeah, they got busted because you actually could go to NASA's website on their archive of their NOAA data and the Robert Simmons Blue Marble data set, and it showed you in the processing steps that that's where the Himawari 8 was getting its information from. So they people think that the Himawari 8 is giving out a new photo of the Earth every 8 to 10 minutes, and it's actually a photograph, but it's not. It's a digital compile.
That sounds scummy.
Well, to be fair, I don't think the Himawari 8 people ever claimed this is a literal photograph of the Earth. They just said, here's an image of the Earth taken from this satellite. And all the NASA zealots, they're the ones who just took it on faith that this is literally just a single instant snap photograph of the Earth.
Yeah, no, scientists do stupid shit all the time. No, that's fine.
Well, listen, a lot of stuff from NASA is said. It's a composite. It's a model. It's an overlay. it's a render,
Mm-hmm.
et cetera. And it's the common people who then say, wait a minute, this is what the Earth actually is at this moment in time. But NASA never claimed it. In fact, the amount of images that are actually claimed to be a true photograph of the Earth are very few. You know what's funny, dude, is there's a guy who made a documentary called A Funny Thing Happened on the Way to the Moon. And in that documentary, he has footage of the Apollo astronauts doing what appears to be faking a image of the Earth while they're in a high altitude balloon capsule.
Really?
Looking out a port window. They're looking out a port window and they're manipulating it to make it look like the Earth they're looking down on. It has like a rounded feature to it. Yeah.
There's an astronaut. He's like a local astronaut that we know. He has like
go
pictures
ahead.
of the. He has like pictures of Earth. He sent it to the Syrian government.
Okay, that's fair. Is he an Apollo astronaut?
I don't know the name of the spacecraft he went on.
Okay,
I think
I'll put it to you like this. I'll put it to you like this, my friend. I'll make it simple. He is not an Apollo astronaut. And that means he has not been far enough away from the Earth to get a photo of the whole Earth. At best, he has a photo from low Earth orbit. And unless he's been beyond the ISS, he could only see 3% of the Earth. So taking an alleged photograph of 3% of the Earth isn't going to tell me what the entirety of the Earth is, my friend. Not going to happen. So, in case you didn't catch that, the only people in the history of mankind who have been far enough away from the Earth, so-called, is the Apollo astronauts. That's it. Everybody else is not far enough away from the Earth to take an image of the whole Earth.
No, I don't mean take a image of the entire Earth. I mean like take a image that's big enough, that's like far enough for you to clearly see the curvature. I mean, you can kind of see it from airplanes, but I did see it from an airplane, but I don't know about how far you need to do that. You need to like 100% see it, and it's like very clear. I don't think it's very high too.
Listen, you have to be more than 700 miles away from the Earth, dude.
700 miles? No,
Yeah.
I think I flew below that. No,
Listen,
I saw it.
listen. No. What I'm telling you, sir, is that what you saw was not curvature of the Earth. That's what I'm telling you. According to the dimensions of a ball, 3,959 mile radius, there is no way in hell you saw the curve of the Earth from 35,000 feet in a commercial jetliner, dude. Did not happen. Now, don't get me wrong. I don't deny that what you saw what appeared to you to be curve, but that curve representation was not being a representative of the geometry of the Earth. That was just a curve in the image that was being resolved in your eye. Because here it's very simple, and I could prove this so simply. In order for there to be a curve, you have to have a differential, right? In the apex or the height from point A to point B to point C. So point A and point C have to be lower than point B, which would be the high point in the middle. You agree?
Sure, yeah. It has to look like meridian to you.
Fair enough. Correct. Or if you flip the axis, it would be further. Either way, there has to be a different distance between point A and point B than point C. So
yes,
the problem is,
they need to be aligned.
Correct. So here's the problem, friend. Here's the problem. The horizon, which is what you think you saw being curved, on a sphere, if you were on a sphere, the horizon would be the exact same distance away from you in all directions. And it would be at the same angle drop from where you are in all directions. So that means that point A, B, and C all have equal values. So if they all have equal values, how in the possible heck did you see a curve?
Just 1 second.
The answer is you didn't. Yeah, the answer is you did not see the curve of the Earth, sir. That's the answer. Now, if you don't trust me, I can quote you two astrophysics and astronomy professors at doctorate level that agree with me if you doubt me. But it's not about doubting me. It's just the simple math, dude. It's the simple fundamental principles of geometry. If there's no difference, then there's no difference. It's that simple. And in order for there to be a
So,
distance difference in those angles, go ahead.
Callaghan, what did you say that I should see if the Earth was a sphere?
Listen, if the Earth's a sphere, the horizon is the same distance away from you in all directions. Do you agree?
Well, the horizon is the same distance on all what?
If the Earth is a sphere and you're claiming the horizon is caused by the Earth being a sphere, then the horizon would be a circle traced around you, and the distance from you to the edge of that circle would be the same distance no matter which way you look, right?
Oh, yeah, now I understand what you're saying. But I didn't see the entire thing because like the plane is like I only have like.
I know that. You only saw a limited field of view, okay, from outside one side of the plane.
Yeah, I
But
didn't see
here's
the
the problem,
entire
dude.
thing. Yeah.
Right. But here's the problem. You saw what appeared to you to be a curve where the left and right were lower than the middle. That's what you thought you saw, right?
No,
Now, I'm not disagreeing with you. I'm not disagreeing with you that that's what you saw. But what I'm trying to tell you is that at 35,000 feet, the angle from you to the horizon and the distance from you to the horizon would be equal 360 degrees around you. So there's absolutely no difference in point A, B, and C. So the idea that you saw the middle higher than the left and right makes absolutely no sense with that geometry because there's no difference. There's no angle difference and there's no distance difference. So there's absolutely no reason why it would be curved. So what you saw is clearly not the curve of the Earth, but it's an optical curve. And that's what I meant earlier by you see things with your eyes, you make assumptions and inferences about it, but then upon deeper scrutiny, you find out that it's not necessarily the case. So you saw a curve with your eyes. I don't disagree with that, but that doesn't mean the object you're looking at is curved.
So I saw like a disc.
No, you didn't see a disc, dude. You did not see a disc. If you claiming to have saw a disc, go ahead and draw me what you saw out your plane window.
I have pictures. I took a lot of pictures.
You took a picture of a disc from an airplane window.
Not a disc, but it looks like a disc.
It doesn't even look like a disc from an airplane window, dude. The only thing possible that you saw from your airplane window, if you're looking down, is nothing but land. And if you tilt your camera up, you'll see land or water give way to sky. And then what you saw is the boundary between the earth and the sky either appeared to be straight or have some subtle curvature to it. That's all you could have possibly saw. There's no disc, there's no circle, there's no globe. All that you saw was the color field of the ground and the color field of the sky have what appears to you to be either a line that is straight or curved between the two. That's it. That's all you could have possibly seen. There's nothing else possible to have been seen. Now, here's the problem, my friend. We've got people on the globe side who believe the Earth is a globe that say there's no way you can see curvature at 120,000 feet. We've got people on the globe side say you shouldn't see curvature at 250 miles away. And then we've got images at different heights that have different curvature rates. So we've got an inconsistent presentation that this is evidence that the Earth is a globe. So we actually need greater evidence than just a myriad of conflicting pictures and conflicting claims. We actually need measurements of the surface itself. And so if you do have measurements of the surface of it actually being curved to then prove your inference is correct, that the reason why things disappear is because the Earth is curved, so actual curvature proof, then we'd love to hear it. But that being said, I have to get to work because I'm at where I'm at now. And
Do you
so
know?
I'm going to leave you with that, friend.
Do you know what a mile, a nautical mile is?
Yeah, it's a model projection.
Yes, but what? But do you know what's the value of a nautical mile? Like how many meters it is?
It's either, well, I don't know it in meters, but it's 69 miles
It's
per
around
degree.
like it's 1865. That's like the standard that we use, but it's not really. But do you know how we got the number?
Yeah, by assuming the Earth is a globe. Yeah.
But how does that number like get us exactly where it needs to get us on a map? Like how does that number work if we're not really on like a sphere? Not a sphere, on like a, if that distance isn't accurate.
It doesn't get you exactly where you want to
It does, yes.
go. No, it doesn't.
Dude, it does. It's literally my job.
Okay, so then so what you're saying is you do celestial navigation, right?
Not celestial, that's the terrestrial.
What?
No, celestial is
So
different.
you do terrestrial navigation on the water?
Yes, on water. It's like terrain. We consider it as
Listen,
terrain.
dude, when you're out at sea, the only relevant reference you have is the celestial sphere. And so you're reverse engineering sightings to the stars to figure out where you are, and then using an almanac to get distances based on nautical miles to different locations. And then you use that to readjust your course, and you arrive generally in a vicinity of where you want to be. So it's not exact at all, and it is a reverse engineering of the assumption that the celestial sphere matches the terrestrial sphere. So, like I said earlier, it's a model. And with that, I'm out of here. If you got Earth curve proof, like of the actual surface, by all means, post it in the chat. But I have to go. So, peace out. Been fun talking to you.
Have a good day. Yeah.
Right.
What's up, man? I'll talk to you for a little bit.
Hey, I'm like playing a video game this entire time, so I'm just like I don't want to.
It's all philosophy for you, right?
Hmm?
It's all philosophy for you. It's not. There's no real world observation for you. It's just a philosophical thing, and so you're just arguing philosophies, right?
There's no real world observation.
I mean, if you had one, you'd present it, right?
Do you not trust your not instinct? Like, do you not trust your senses?
Yeah, they tell me that I'm not supposed to trust my senses. In fact, I'll show you exactly what they say. Give me a second. It's just fucking wild, man. You are being lied to by your own senses. Right now, you are strapped to a rock spiraling through the cosmic void at 500,000 miles per hour. We aren't floating in a peaceful circle. We are being violently dragged across the Milky Way. My senses don't tell me that. My senses tell me that I'm flat and stationary. But this is what they want you to believe. Do you disagree with that?
Sorry, I wasn't really with you. I'm like in a team fight.
Well, it sounds like you should focus more on that.
Sounds like what?
Sounds like you should focus more on that. We'll find somebody else to talk to.
Cool.
Hey, how you doing, Serene Storm? And then good morning, guys and girls. And then Promu, how you doing? Yeah, go ahead and mute your mic. Get good. You're busy
You
playing
can
video
hear me?
games. I promise you, this is not a room where you can play video games and have this discussion.
No, I just like talking to random people about random stuff when I'm playing because I'm really bored.
Right, but this isn't a place to have a conversation about nothing.
Yeah,
Right?
that's what talking is.
Like you're not even paying attention, so it's not really a conversation. Like if you were engaging in a conversation of good faith, you would stop what you're doing, just like I stopped what I'm doing, right?
You
And
stop what you're doing?
yeah,
What were you doing?
I just got to the gym, so I'm on pause right now, trying to have a good faith conversation. But I mean, you don't want to do that. You want to.
No, I'm not doing that. Sorry if I distract you from doing something.
You're not distracting me. You're distracted. See, here we talk about empiricism, right? We don't talk about hypotheticals. We don't talk about computer models, right? We talk about real world observations and how we go about determining whether or not those real world observations measure
No,
up to.
the thing is, I said I'm a navigator, right? So the entire science of the navigation is all it's the science of going from point A to point B without like getting lost in the sea. And sea, there's nothing in the sea. It's just like water and shit. So
Right, because you have no landmarks.
yeah, so the entire science is based off of information that rely on that the Earth is a sphere, right? It's not really a sphere; it's a globe, right? But
Not really.
the
You're just taking the celestial sphere, right? The way
yes,
you observe things from you as the observer centric, um, you know, point.
what I'm
So
saying is that
observer centric.
what I'm saying is that since the data that we put in that relies on the Earth being a globe, right?
It
Since
doesn't
the data
rely on the
we
Earth
put
being
in
a
to
globe.
plan our voyage,
It doesn't rely on that.
it does, yes.
It doesn't. If it did, Christopher Columbus wouldn't have got lost because they had globes back then too.
He did get lost.
I know. If the
Yes,
globe worked, he wouldn't have got lost.
maybe he was just like an idiot or something. I don't know. I mean, in like the modern time, when it's advanced.
Have you ever noticed that when you
Columbus.
use GPS, and I'll let you go in just a second, DJ. I'm just going to say this real quick, and I'll hand it over to you.
No,
Haven't
no,
you
no.
ever
I'm good.
noticed when
Sorry.
you're using GPS, like sometimes it'll take you off course, or you'll notice that you're not in the location where GPS is telling you, and then all of a sudden it'll buffer and have to recalculate.
What it takes me where? It takes me where?
It has to buffer and recalculate because
Oh
it's
yes.
not in the location where it's supposed to be.
No, GPS has like an error window. Yeah.
Yeah, so when it's buffering and recalculating, all it's doing is it's re-implementing the observer-centric position.
No, that's not what how a GPS works.
Yeah,
See,
it's taking
GPS works. Do you know how a
it's
radar
taking
works?
the observers. All GPS is a computer model of the celestial sphere from an observer-centric point. They've taken thousands, if not millions, of data, and basically calculated everything based off of the observer centric
No, see,
observation.
let me tell you how GPS works. So
Okay.
you know how radar works, right? You send a point of you send light, right?
Mhm.
You know the speed of light, what the speed of light is. You send it, the light hits something, and then it comes back to you. When it comes back to you, you have like you know the time that you sent the thing, and you know the speed. All that's remaining is the distance. You can get
Yeah,
distance if you have
and when it's wrong, and
what?
when it's wrong, it does an assumptive calculation until it can reconnect and figure out exactly where it's at.
But how is like what? How is it like? How does it assume this if when I'm usually like arriving right where I want to arrive if I use it?
Right, because you were already on a path at a certain speed, right? You were already on that path, and so they assume that you haven't deviated from that path, and then it just keeps pinging until it gets the result that it wants.
But we go on sea for very long times, and I don't know if it can.
It calculates distance on a map from coordinate to coordinate. It doesn't measure actual distance traveled.
Coordinate to coordinate? Yes, it does.
Yeah, it's calculating. It has one job to do, and that's put your ship, your airplane, car, whatever, on the coordinate reference grid somewhere. And it will calculate your distance and your speed based off of where it puts you on the grid, regardless of how fast you're actually going and how far you've actually gone.
Yeah, see, when we're going on like long voyages, we go for like sometimes 30 days or something. We go through a course. We set a course and we go through it, right? So
Yeah,
most of the time, so every time,
I'm not saying it doesn't work.
no, just 1 second. So one time, all the time we get wind, we get current, we deviate from our location, from our like original course all the time, and we make corrections to that. So how does the GPS know how to like correct for these things?
What do you mean? How does it know how to correct for all that?
Yeah, like how does it know where you are?
GPS calculates your position based off of where you should be on a coordinate reference grid,
Yes,
regardless of where you
right.
actually are.
Mm. But wouldn't it be way off if we like go through a long area of uncharted
Yes,
territory, which is the sea, and
absolutely. Yes,
it
it would.
would be way
100%.
off. Yeah, especially that we experience a lot of current and a lot of wind and stuff. So
Yeah, you need a
how
way
it?
to actually measure that distance without GPS.
Yes. So how do we like accurately get our position right the entire time?
Well, you can use GPS and it works,
Yeah.
but it's not necessarily going to be accurate or reflect what's happening in the real world. In fact, if you want accuracy, you're not going to use latitude and longitude. You're not going to use a spherical coordinate reference grid. You're going to use GPS on a flat local tangent plane.
No, that's not true.
Yeah, that is absolutely correct. It's how the military does it. You want to see some stuff? See some documents on this?
Like yes, we eventually like fix our location on a flat map. Yes, but the
No,
like
not
the
a flat
way.
map. No. On
Yes,
a
but a flat map is only for like a very small area of the Earth. It doesn't mean the Earth is like
yeah,
only that
but
flat map.
why would this increase precision if Earth isn't really that shape?
No, it's like easier to edit it that way
It's not
because
easier, it's more accurate.
no, it's not accuracy thing. You can't like put a fucking ball on a table and like do
When they want
calculations.
accuracy, this is what they do. So why don't you sit tight while I show you that you're wrong and I'm correct?
Okay, cool.
All right, I'm going to
Any
pull
of
up
you
some
play
documents.
Counter-Strike? Do you play Counter-Strike?
No, I don't play kids games.
Cool. Is anyone who's listening plays Counter-Strike?
No.
Cool.
Nope. Don't have time to play video games. Grown man stuff to do.
Yep.
The burn.
All right, so I'm going to find for you one such example from the United States Navy postgraduate school. There we go. This document is open source. There's nothing wrong. You can go find the complete one yourself. If you want a copy, just ask me. Okay? Abstract. The purpose of this thesis is to incorporate the GPS and inertial navigation system for the guidance of an unmanned aerial vehicle seeking precise navigation in a local tangent plane. By applying the differential positioning technique, GPS position data becomes more accurate. This position can then be referenced to known location on the ground in order to give the aircraft's position in the local tangent plane.
Yeah.
The differential GPS improves accuracy by assuming planar coordinates, not spherical. This is one of many examples. I mean, this what I'm telling you isn't like unknown. In fact, the entire government of the United Kingdom
Well, yes,
for
the
property
number
disputes
that
use flat coordinates, not spherical ones. The British National Grid System. Let me see what it looks like. The British National Grid System is a series of squares, 5 by 5 squares, each 250 kilometers by 250 kilometers. And if you were to put it on a globe, it doesn't. Here we go. Here's an example. Obviously, it doesn't match. So how do you know which one of these is true? Great Britain, their ordnance survey. This is for determining the metes and bounds of property between landowners, for precision guidance of military systems. Why would they use that?
do you mean the
A flat square grid.
but when you use the flat square grid on a globe, it doesn't give off accurate.
How do you know that? Why do they say it's more accurate?
I don't care what they say, but if I do this on my job, I get fired because I if I go to if I do this, I go to like a different port than when we're going.
Obviously, it doesn't match. So the question is, how do you
That's
determine
wrong.
which one of these is true? Is
Well,
latitude and longitude the right one, or is the orthogonal Euclidean flat plane geometry the right one?
both of them have their uses. Like you
They
use
sure
this.
do.
Yes, I mean the globe is the real thing, but you use
Do you know that's true? Especially when we have all these
the
sources that say it's more accurate not to use it.
yes, we use the 2D variant of like a surface when we're dealing with small measurement things. If you're planning long voyages, then the curvature of the Earth can affect your calculations.
Yeah, how do you know it's actually curving? How do you know the curved distance is the right distance?
Because we use the how do you say it? We use the. Do you know what sine and cosine means? I don't know how they like translate.
Yeah,
it
in
in
fact, I taught you that latitude and that longitude is determined by your cosine of the latitude.
Yes, so you know them.
I didn't
you
know
know
that
what
earlier, and I had to tell you
tangent.
this was the case.
So sine, cosine, tangent, and there's a fourth one. It's called half. It's 1 on the 1 minus cosine of theta, which is the angle that you need. Half is the spherical angle. And we use that to for our calculations in long voyages because
I know you do, and I'm challenging it.
no, we do use it.
I know you do, but I'm challenging its accuracy based off
We
of
do.
real world measurements.
We arrive on time when we need to arrive. What are you talking
I
about?
know, because you don't really know how much ground or water you actually covered.
Yes, we do know that.
Well, you have a calculated distance on a map, regardless of how much you actually traveled in real life.
No, we know all of that. Like we know all of that information.
How do you know that this is accurate? How do you know that these
We
curving
arrive when we're
distances
supposed
are
to
accurate?
arrive based on those calculations.
Based on those calculations, how do you know the calculations are accurate if you never measured them to determine they're accurate?
Dude, like we know our engine's capacity. Like
Yeah, you're
we know
speaking in
how
circles.
Sure. What?
Yeah, you're speaking in circles. I mean, you can't determine how far you actually went by just
Yes,
measuring how much heat you generated with your engine.
No, not heat, power.
Yeah, work.
Your distance and trip time and stuff, it's matching up with the coordinate system, right, that you used in the first place, right? I think Yoder saying that. How do you know that the actual distance, right, like the raw distance, right, not just the distance that you're being told by your computer, right, that has
Okay, so I'll tell you
a
what.
globe baked into it. Okay, you can navigate using the spherical coordinate system, but you don't know if you're actually doing those exact
So
distances
yes,
or not.
let me tell you how. So we know our speed based on like the rounds per minute and the weight of the ship. So we get that number, which is our speed, and then we input it into a form. Just 1 second. We input it into a form, right? So then we keep doing that over the course of the voyage. Like we do it every 4 hours, and by the time we arrive, we get we arrive when we expect to arrive, which means that that speed is correct.
How does it measure the speed? Sorry, does it measure the drag against the water or something like that?
So if your speed is wrong, that means then your timing is wrong, right? If you
How do you
can't
know your
measure
speed?
your speed correctly, that means you can't arrive when you expect to arrive.
Right. I was asking you how do you measure the speed again? Is it to do with the water resist, the drag against the water, or like what is it? How do you precisely measure the speed, and how accurate is that, and what's it called? Because I want to look into it.
Every just 1 second.
You could say I don't know, or